So write down the third type. The reactions involving ROH as a whole. Reactions involving ROH as a whole. So we have come across the reactions in which either R bond OH was the active portion of the alcohol, or RO bond H portion was active. But today we move on to discuss the third type of reaction in which as a whole the ROH will be taking part. So under this, we shall first talk about, write down number 1, dehydration of alcohols. Dehydration of alcohols. So you all are familiar with the term what is dehydration. Dehydration का मतलब क्या होता है? What is the meaning of the term dehydration? Can anybody tell me? Even we suffer removal of water. Even we sometimes suffer from dehydration. That is, there is a loss of water from the body during the summer days or due to some illness, and that ultimately results in dehydration. अब क्वेश्चन ये बनता है कि अल्कोहल को डिहाइड्रेट करने के लिए कुछ तो देना पड़ेगा, अपने आप तो they will not be undergoing dehydration. So what should be given to alcohols so that they undergo dehydration? The answer to this question is they must be given some dehydrating agent. What is a dehydrating agent? Dehydrating agents are those which remove the water from the molecule. And one such dehydrating agent is concentrated sulfuric acid. And depending upon the type of alcohol that we take, alcohols can be further categorized into 1 degree, 2 degree, and 3 degree alcohols, as we know. And depending upon the type of alcohol that we take, accordingly, the dehydration of the alcohol can be carried out. So before we move on to the reactions, let me put some important points to you that what generally are the steps involved in the dehydration process. So suppose we consider this point, the acidic dehydration of alcohols. Two alkenes occurs through the formation of carbocation. Okay, so what is the meaning of it? The meaning of it is during the dehydration process, there is removal of water from the alcohol, resulting in the formation of alkene. But because during the course of the reaction, the intermediate produced is a carbocation. So obviously that alcohol will show the reaction the fastest who will be producing the most stable carbocation. And we are familiar with the fact that out of different carbocations present, which carbocation is most stable? Is it 3 degree, 2 degree, or 1 degree? Which carbocation? 3 degree. So because 3 degree is most stable carbocation, so therefore the dehydration process also follows the same order. Hence, the reactivity order towards dehydration is 3 degree greater than 2 degree greater than 1 degree. तो 3 डिग्री जो है वो फास्टेस्ट डिहाइड्रेशन दिखाएगा एज कंपेयर टू 2 डिग्री एज कंपेयर टू 1 डिग्री. तो अब क्वेश्चन ये उठता है कि व्हाट इज डिहाइड्रेशन, दैट वी हैव डिस्कस्ड. व्हाट इज द ऑर्डर ऑफ डिहाइड्रेशन, दैट आल्सो वी हैव डिस्कस्ड. नाउ लेट अस ट्राई टू अंडरस्टैंड दैट व्हाट एग्जैक्टली हैपेंस in case of dehydration. So in order to show dehydration, the alcohol that we take must have at least one beta hydrogen. Now we know that the carbon next to the functional group is called the alpha carbon, and the carbon next to the alpha carbon is called beta carbon, and the hydrogens bonded to the beta carbon is called beta hydrogen. So if I just carry out this process by treating this with concentrated H2SO4 at nearly 443 Kelvin, temperature is important. So there will be removal of water from the molecule, and the water gets removed from the molecule, resulting in the formation of an alkene, and water is removed. So hence we say that if this is a 1 degree alcohol, okay, which are not so easily dehydrated, तो उनको डिहाइड्रेट करने के लिए रिलेटिवली हाई टेम्परेचर की जरूरत पड़ेगी, 443 केल्विन. लेकिन सेम अगर हम 2 डिग्री और 3 डिग्री अल्कोहल लें तो वी डोंट रिक्वायर दैट मच ऑफ टेम्परेचर, बिकॉज रिलेटिवली जो 2 डिग्री और 3 डिग्री अल्कोहल्स हैं, दे आर मोस्ट, यू कैन से, रिएक्टिव टू डिहाइड्रेशन प्रोसेस. तो देख लेते हैं मैकेनिज्म क्या है. व्हाट इज द मैकेनिज्म ऑफ द रिएक्शन ड्यू टू व्हिच द रिएक्शन प्रोसीड्स. अगर हम एक अल्कोहल लें जिसके पास एटलीस्ट 1 बीटा हाइड्रोजन है, एंड वी ट्रीट दिस विद एसिड like concentrated H2SO4 that is capable of providing us H plus ion. So who do you think in the whole molecule is capable of helping this H plus ion?
Sir, oxygen.
Who do you think? Oxygen. The oxygen will invite the H plus via its lone pair of electrons and will form bond with the H plus. And when oxygen forms bond with the H plus, it will be left with only one lone pair, because other lone pair has been utilized in forming bond, and therefore the oxygen which has helped the H plus develops a positive charge on it, making the oxygen highly electronegative in nature, electron deficient in nature, sorry. So ultimately this oxygen requires help, so it is going to take away the electron from this carbon, and it is going to come out as water, and when it comes out as water, so obviously it will be resulting in the formation of a carbocation. This is what I was talking about, that the process goes through the formation of a carbocation, and more stable the carbocation, faster will be the reaction. Now this carbocation is an unstable species because of course carbon has undergone deficiency of electron. So to save this carbocation with respect to this carbocation, one of the beta hydrogens is going to sacrifice its electron pair and it will come out as H plus ion, resulting in the formation of alkene. So this is the mechanism, and H plus comes out as I have already shown. So you can say that H plus acts like a catalyst because it was H plus who introduced the disturbance in the OH group, and thereby removal of water was made possible. And when H plus comes in and disturbs the whole molecule by producing positive charge on the oxygen, so there is a pull of the electron cloud towards the oxygen, and at first the carbon bonded to the oxygen loses the electron, thereby forming the carbocation, and thereafter to further stabilize the carbocation, one of the beta hydrogens get lost. Now in this example that I have provided, there is only one beta hydrogen, as you can see. But if there is more than one type of beta hydrogen, then you get mixture of alkenes, and the majority of the alkene produced will be determined by Seitzeff's rule, which we have discussed during the dehydrohalogenation process. Up to this much you write down, and then we will further proceed to some extra things that we need to learn. Tell me after you have completed writing. So which alcohol is fastest in dehydration process?
Primary.
Is it primary or tertiary?
Tertiary.
Tertiary. Why tertiary? If someone asks you.
Sir, because it has more stable carbocation.
Yes, because the reaction proceeds through the formation of carbocation, and therefore 3 degree, as 3 degree forms the most stable carbocation, so therefore it will proceed, 3 degree will show the fastest reaction. Have you written it down? Can I proceed further? आगे बढ़े, हो गया?
Yes, sir.
सभी ने लिख लिया? So अगर एक से ज्यादा बीटा हाइड्रोजन हो, एक से ज्यादा तरह के बीटा हाइड्रोजन हो, which rule is followed?
Seitzeff's rule.
Seitzeff's rule. क्या कहता है Seitzeff's rule? याद है?
Sir, the more
Sir, carbon containing less number of hydrogen will give its hydrogen.
Yes, the carbon containing lesser number of hydrogen will try to give away the hydrogen. Or in other words, can we say that if there is a possibility of formation of more than one type of alkene, so most substituted alkene will be the major product? बोल सकते हैं? Most substituted alkene याद है कि नहीं? किसे कहते हैं most substituted alkene? C डबल बॉन्ड C के साथ जितना ज्यादा एल्काइल ग्रुप रहेगा उसको कहेंगे मोर सब्स्टिट्यूटेड एल्कीन. Which is the least substituted alkene? कौन सा एल्कीन सब्स्टिट्यूटेड नहीं होता है? Which alkene? Ethene. Ethene is the first member of the alkene family which is not substituted at all. So further continue. The dehydration of (2° and 3° alcohols always occurs in accordance to Seidzeff's rule. According to this rule, the highly substituted alkene is the major product. So Seidzeff's rule is shown by 2° and 3° alcohols. क्योंकि 1° alcohol में तो कोई possibility नहीं है, OH is always present at the corner carbon. तो 1° alcohol में तो एक ही तरह का बीटा हाइड्रोजन रहेगा, लेकिन 2° and 3° alcohols में there is a possibility of having more than one type of beta hydrogen. तो suppose हम लेते हैं ब्यूटान 2-ol. किस तरह का अल्कोहल है ब्यूटान 2-ol? 1°, 2° के 3°?
Sir, 2°.
2°.
It is 2°. तो ये हो गया अल्फा कार्बन, ये हो गया बीटा कार्बन, ये भी हो गया बीटा कार्बन. So in this beta carbon you have 3 hydrogens, in this beta carbon you have 2 hydrogens. So according to the Seidzeff's rule, if this is treated with concentrated H2SO4, you get mixture of 2 alkenes, but1-in and but2-in. लेकिन मेजर प्रोडक्ट कौन सा होगा? That will be determined by which alkene is more substituted. ठीक है? So for that we will have to count on the number of alkyl groups around the C double bond C. तो पहला जो प्रोडक्ट है but1-in, तो C double bond C के सराउंडिंग में सिर्फ एक ही alkyl ग्रुप है, that is an ethyl group. बाकी तीनों हाइड्रोजन्स हैं. और यहां पर अगर हम देखें around C double bond C, how many alkyl groups are there? 2 methyl groups are there. So who do you think is more substituted? but1-in के but2-in?
Sir, but2-in.
Sir,
but2-in. तो but2-in क्योंकि ज्यादा सब्स्टिट्यूटेड है, तो इसीलिए हम इसको बोलेंगे मेजर प्रोडक्ट. और but1-in जो है वो हो गया माइनर प्रोडक्ट. देखो यहां तक समझ आया कि नहीं? Is this much clear to everyone? Yes, Stanton, is it understood? Stanton is present today or not? Shaima, is it clear to you?
Yes, sir.
Others, is it understood?
Yes, sir.
I'm not getting any one of your voices. Yes, am I audible now?
Yes, sir.
Yes, sir.
Yes.
Yes, sir.
Okay, now this much everyone is clear.
Yes, sir.
Yes, sir.
Turn it down.
Yes, sir.
Okay. Now under this topic, I will further extend to a phenomenon which you have not come across so far, because dehydration involves formation of carbocation, and carbocation always prefers stability, and whenever they get the scope of getting converted to a more stable carbocation, so they can show a phenomenon called rearrangement. And this is what we are going to discuss now under dehydration of alcohol. So अच्छी तरह समझना. So we are going to discuss hydride and methyl shift. Hydride and methyl shift. What exactly is hydride and methyl shift? Let us try to understand this. So suppose we have a branched alcohol of this nature, CH3, CH2, CH3, CH2OH. Okay. There is a branching. It's not a straight chain. So of course it's a 1 degree alcohol with a branching, and the branching is found in which particular carbon? Where is the branching found? Is it alpha carbon, beta carbon, delta carbon? Where is it found?
The beta carbon.
Beta carbon. So this is the alpha carbon, this is the beta carbon. Now with the help of the mechanism, if we try to understand it, suppose I put an acid. So we know that the acid, the H plus provided by the acid will be invited by the oxygen, lone pair of oxygen, thereby forming the unstable species. Where oxygen will be utilizing one of its lone pair to form bond. And because it is unstable, as we have discussed already, so it is going to take away the shared pair, resulting in the formation of carbocation. Water will be lost. And carbocation will be developed. Now, what is the nature of this carbocation? Tell me. Is it 1 degree, 2 degree, or 3 degree carbocation?
1 degree.
Sir,
So
1
1
1 degree. Kyun 1 degree? Because this carbocation is bonded to only one carbon. Lekin there is a possibility of conversion of this 1 degree carbocation to 3 degree if from the neighborhood carbon, from the beta carbon, one hydrogen jumps to this position. And this particular phenomenon is referred to as hydride shift. इसको क्या कहेंगे? इसको कहेंगे 1,2 hydride shift. कब होता है यह hydride shift? अगर दूसरे कार्बन के पास हाइड्रोजन है और ये हाइड्रोजन अगर यहां पर आ जाए और पॉजिटिव चार्ज अगर इस कार्बन पे डेवलप करे, तो इट इज गोइंग टू गेट कन्वर्टेड टू अ मोर स्टेबल कार्बोकेटायन, CH3 CH2 CCH3 CH3, और ये हो गया तुम्हारा कार्बोकेटायन। पहले था 1 डिग्री, लेकिन हाइड्रोजन जब हाइड्राइड होकर इधर शिफ्ट हो रहा है तो इट इज गेटिंग कन्वर्टेड टू 3 डिग्री। बट जंप इज अलाउड ओनली फ्रॉम द नेबरहुड कार्बन, नॉट टू एंड नॉट फ्रॉम एनी अदर कार्बन। तो तब जाके हाइड्राइड शिफ्ट होगा। एंड with respect to this carbocation, now there are 3 beta carbons, but 2 types of beta hydrogens। 2 तरह के बीटा हाइड्रोजन्स हैं, ये दोनों एक तरह के और ये एक और दूसरी तरह के। तो अल्टीमेटली अगर हम सिर्फ मेजर प्रोडक्ट को पकड़े, यहां से अगर H+ निकल जाए, तो दिस पर्टिकुलर बीटा कार्बन विल फॉर्म द मेजर प्रोडक्ट। देखो ये तुमको समझ आया कि नहीं? इट्स एन इंपॉर्टेंट फेनोमेनन, 1,2 हाइड्राइड शिफ्ट। So again I am repeating, if there is a possibility of shifting hydrogen from beta carbon to the alpha carbon and it leads to a more stable carbocation, then 1,2 hydride shift occurs। नाम इसलिए दिया है 1,2 क्योंकि कार्बोकेटायन को हम कार्बन नंबर 1 पकड़ेंगे, एंड विद रिस्पेक्ट टू कार्बन नंबर 1 जो बीटा कार्बन है वो कार्बन नंबर 2 है। तो अगर कार्बन नंबर 2 से हाइड्रोजन शिफ्ट करके 1 में जाता है, तो 1 डिग्री कार्बोकेटायन इज गेटिंग कन्वर्टेड टू 3 डिग्री कार्बोकेटायन। तब हमको एक रीअरेंज्ड प्रोडक्ट फॉर्म करने को दिखता है, हमको मिलता है। तो wherever we have got branched alcohols, so what we expect in the product, we do not get that, we get something else, and that can be explained only on the basis of either hydride shift or methyl shift। तो यहां पर जो हमने एग्जांपल दिया है that is 1,2 hydride shift। So though there will be mixture of 2 alkenes because there are 2 types of beta carbons, but I have drawn only the major product, keeping in mind the Seitzer's rule। Is it understood, Vedansh? What is 1,2 hydride shift?
Yes, sir.
So can anybody tell me when will hydride shift occur?
Sir, if the beta carbon can donate the hydrogen.
Okay. Now, can it donate hydrogen or give away the hydrogen in every case, or only when there is a possibility of conversion from less stable carbocation to more stable carbocation?
Sir, only when there is a possibility of conversion from less stable to more stable carbocation.
Yes. So that has to be taken care of.
Sir,
ठीक है, hydride, हाँ बोलो।
sir, hydride shift occur only when there is branching.
Yes, because when there is branching, there is a possibility of getting converted to 3 degree carbocation, na? When there is branching, the hydride shift will lead to 3 degree carbocation or not, and branching should not be present on any carbon, but it should be present on the beta carbon। बीटा कार्बन में होना पड़ेगा ब्रांचिंग, तब जाके मिथाइल शिफ्ट या हाइड्राइड शिफ्ट देखने को मिलता है। ठीक है, क्लियर अप टू दिस मच? हाइड्राइड शिफ्ट का एग्जांपल समझ आया?
Yes, sir.
Okay. Now let us try to understand the methyl shift as well with the help of another example। So in order to understand the methyl shift accordingly, I take this example, CH3, 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 CHOH, CH3. यहां पर अगर हम एज यूजुअल एसिड दें तो ऑक्सीजन इज गोइंग टू इनवाइट द H+, producing the unstable intermediate where oxygen has developed positive charge. So to save oxygen, it is going to take away the electron from the next carbon. Water comes out of it. CH3, 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 CH plus, CH3. What is the nature of this carbocation?
Sir, 2 degree.
It is 2 degree. अच्छा, अब ये 2 डिग्री 3 डिग्री बन सकता है अगर इसका जो नेबरहुड कार्बन है उससे पूरा मिथाइल ग्रुप शिफ्ट हो जाए, तो इसको हम कहेंगे 1,2 मिथाइल शिफ्ट. If the whole of CH3 comes here, then you will see that the carbocation that is formed is a 3 degree carbocation. क्योंकि इस कार्बन के पास कोई हाइड्रोजन नहीं है. अगर हाइड्रोजन होता तो हाइड्राइड शिफ्ट होता, because out of hydrogen and methyl, who will find it more easier to move? Of course hydrogen, because it is smaller size. लेकिन यहां पर कोई हाइड्रोजन नहीं है, सारे के सारे मिथाइल ग्रुप हैं, तो कोई भी एक मिथाइल ग्रुप पूरा अपने आप को शिफ्ट करेगा जब 2 डिग्री कन्वर्ट होगा 3 डिग्री में. एंड विद रिस्पेक्ट टू दिस कार्बोकेटायन, यहां पर हम अगर बीटा कार्बन देखें तो 2 तरह के बीटा कार्बन है, बट 3 बीटा कार्बन आर देयर. लेकिन ये दोनों तो एक ही तरह का बीटा कार्बन है, सो इसको हम एक पकड़ेंगे. तो मेजर प्रोडक्ट अगर हमको फाइंड आउट करना है तो यहां से अगर हम H+ निकालें तो दिस इज गोइंग टू प्रोड्यूस द मेजर प्रोडक्ट, एंड अल्टीमेटली द डबल बॉन्ड विल बी जनरेटेड इन बिटवीन दीज 2 कार्बन्स. तो ये हो गया तुम्हारा मिथाइल शिफ्ट. तो बोथ इन हाइड्राइड शिफ्ट as well as methyl shift, what common thing you are able to get? Yes, can anybody tell me?
More stable carbocation.
Yes, they are getting converted to more stable carbocation. And we can find out one thing in both the examples, that the alcohol must have branching in it to show such kind of shift. Which is more preferred, hydride or methyl?
Sir, hydride.
Hydride. But if in the neighborhood carbon there is no hydrogen, then only the methyl shift will occur. But both of them will lead to the formation of the most stable carbocation, that is 3 degree carbocation. So whenever you come across any branched alcohol, so immediately it should come to your mind that what you expect and what you are actually getting are completely different products. अगर हम ये वाला reactant आपको दें, and if I simply ask you that what will happen when it is dehydrated with concentrated acid, so one might think that this is the alpha carbon, there are 2 beta carbons. इस beta carbon के पास तो कोई hydrogen है नहीं, so there will be only one product, one alkene that will be produced where double bond will be in between 1 and 2. लेकिन हमको जो प्रोडक्ट मिल रहा है वो कंप्लीटली डिफरेंट है. यहाँ पर डबल बॉन्ड जो है वो कार्बन नंबर 2 और 3 के बीच में फॉर्म हो रहा है, तो ये किस लिए हो रहा है? इट इज बिकॉज ऑफ 1,2 मिथाइल शिफ्ट। तो 1,2 हाइड्राइड शिफ्ट और 1,2 मिथाइल शिफ्ट, ये जो दो तुम्हारे रीअरेंजमेंट रिएक्शंस हैं, इनको हमको ध्यान रखना पड़ेगा। डन? इज इट क्लियर टू एवरीवन?
Yes, sir.
Okay, now keeping in mind the hydride and methyl shift, let me put a question before you so that you can understand the phenomenon in a better way. Suppose अगर हमको ये वाला रिएक्टेंट दिया जाता है और पूछा जाता है कि इसमें अगर हम कंसंट्रेटेड एसिड दें, डिहाइड्रेशन करें, तो कहां पर डबल बॉन्ड प्रोड्यूस होगा? So with the help of mechanism we need to understand. ये है ऑक्सीजन which will be inviting the H plus through one of its lone pair. Oxygen will pull away the electron from the carbon, resulting in the formation of, okay, तो वाटर निकल गया, इस तरह का कार्बोकेटन प्रोड्यूस हो रहा है।
1 degree.
1 degree. Now what is the chance to get it converted to a more stable carbocation? Will it be a methyl shift or will it be a hydride shift?
The
Hydride shift. देखो, with respect to this carbocation, this is the beta carbon. Is this beta carbon associated with any hydrogen or not?
Yes, sir.
Yes. How do I know whether it is associated with hydrogen or not? Count on the number of visible bonds. There are only 3 bonds, which means that the fourth bond consists of hydrogen. तो ये हाइड्रोजन पूरा का पूरा इधर आके लगेगा and ultimately इसको हम कहेंगे 1,2 हाइड्राइड शिफ्ट। And when 1,2 hydride shift occurs, so the positive charge will be generated on this. Now, this was 1 degree. What is the nature of this carbocation? Tell me.
So 3 degree.
It is 3 degree. Now, with respect to this carbocation, how many beta carbons are there?
Three.
ये बीटा कार्बन हो गया, ये बीटा कार्बन हो गया, ये बीटा कार्बन हो गया, बट ये जो 2 बीटा कार्बन है एक ही तरह के हैं, ये कंप्लीटली अलग तरह का है। तो मेजर प्रोडक्ट जो होगा आफ्टर दिस कार्बोकेटायन लूजेस H plus आउट ऑफ इट, डबल बॉन्ड बाहर की तरफ फॉर्म होगा कि अंदर की तरफ फॉर्म होगा? According to the Seitzeff's rule, which alkene will be more substituted if the double bond is inwards or the double bond is outwards?
So inwards.
Sir,
Inwards. Very good. तो जो मेजर प्रोडक्ट होगा वो होगा ये, और जो माइनर प्रोडक्ट होगा वो होगा ये। तो दिस इज द मेजर प्रोडक्ट, दैट इज द माइनर प्रोडक्ट। देखो यहां तक समझ आया कि नहीं? ठीक है, क्लियर हुआ?
Yes, sir.
तो डिहाइड्रेशन ऑफ एल्कोहल्स में हमने बहुत कुछ सीखा. फर्स्ट ऑफ ऑल वी डिस्कस दैट डिहाइड्रेशन किसे कहते हैं. ये भी एक तरह का बीटा एलिमिनेशन है, क्योंकि OH तो जाएगा ही मॉलिक्यूल से, लेकिन OH अपने साथ किसको ले जाएगा? बीटा कार्बन को ले जाएगा, बीटा हाइड्रोजन को ले जाएगा. तो मिनिमम एक बीटा हाइड्रोजन होना ही चाहिए मॉलिक्यूल में, और अगर एक से ज्यादा तरह के बीटा हाइड्रोजन हो तब सेड्जेफ्स रूल हम फॉलो करते हैं. लेकिन द ट्रेंड, द रिएक्टिविटी ऑर्डर टुवर्ड्स दिस पर्टिकुलर रिएक्शन इज 3-1, क्योंकि हमने देखा कि ड्यूरिंग द मैकेनिज्म कार्बोकेटायन इज प्रोड्यूस्ड, और क्योंकि 3 डिग्री कार्बोकेटायन जो है वो मोस्ट स्टेबल है, तो हर समय रिएक्शन में इफ पॉसिबल इट विल ट्राई टू फॉर्म द 3 डिग्री कार्बोकेटायन. और मिथाइल शिफ्ट, हाइड्राइड शिफ्ट होने के बाद अगर 3 डिग्री कार्बोकेटायन फॉर्म हो जाता है, it will always try to form that, and from there onwards there will be dehydration occurring. उसके बाद dehydration occur. Is it clear, girls? Is it understood? Kanishka?
Yes, sir.
Okay. So actually whenever there is branching with respect to the beta carbon, then only you will get such kind of hydride shift or methyl shift possible. But if there is no branching, then of course there is no problem. Whatever you expect, you get the same product. So after dehydration, we now move on to number 2, under third type of reaction only, and that is called oxidation of alcohols, another very important set of reactions. Oxidation of alcohols. Now the question arises that there are 3 types of alcohols: 1 degree, 2 degree, 3 degree. And in order to carry out the oxidation, we need to use some oxidizing agent, because until and unless we put in some oxidizing agent, oxidation will not be possible. But there is a difference between 1 degree, 2 degree and 3 degree alcohols, because of which the behavior towards oxidation reaction is also found to be different for 3 types of alcohols. Now, what is 1 degree alcohol? 1 degree alcohol is that alcohol where the carbon bonded to OH has minimum of 2 hydrogens associated with it. What is 2 degree alcohol? The carbon bonded to OH has only 1 hydrogen linked to it. And 3 degree alcohols, the carbon bonded to OH has no hydrogens. All are alkyl groups. Now remember one thing, that this is oxidizable hydrogen, and these are also oxidizable hydrogens. Okay. So in case of 1 degree alcohol, this is a functional group OH, so obviously it is common to everyone, and it has 2 oxidizable hydrogens. This is not oxidizable. These 2 are oxidizable hydrogens, which means that 1 degree alcohols can be oxidized in 2 steps. Duta stepot ami tak oxidize koribo paru, one after another. If you keep on removing it, then it is said to be oxidation, because oxidation, as you know, has various definitions. It can be defined as addition of oxygen, it can be defined as removal of hydrogen as well. So in case of 1 degree alcohols, there are 2 oxidizable hydrogens. In case of 2-degree alcohols, there is one oxidizable hydrogen, and in case of 3-degree alcohols, there is no oxidizable hydrogen. So forget about these hydrogens. These are common. They are not oxidizable. The hydrogen bonded to the alpha carbon are oxidizable hydrogen. So if we oxidize the 1-degree alcohol, so at first what will happen? It will get converted to an aldehyde. Okay, this is an aldehyde. And as you can see, only one hydrogen is getting removed. Any one of the two hydrogen you are removing along with the hydrogen of OH. So that is common because that will be getting removed every time, provided it gets its partner to get removed. But after one hydrogen gets removed, it is still having one oxidizable hydrogen. And therefore, it has a further scope of getting oxidized. And you get carboxylic acid. 1-degree alcohols first get oxidized to aldehydes and then finally gets oxidized to carboxylic acid, all containing same number of carbon atoms. But in case of 2-degree alcohols, it will show only one-step oxidation as it has got only one oxidizable hydrogen. And what product you are going to get from 2-degree alcohol? You get ketones. Can ketones be further oxidized like aldehydes under normal conditions? What do you think?
No, sir.
Why not?
Sir, no oxidizable hydrogen.
Sir,
No
because it has no
oxidizable hydrogen.
oxidizable hydrogen.
Yes, it is not left with any oxidizable hydrogen, so ketones are stable to further oxidation. अच्छा, 3-degree alcohol के बारे में क्या कहोगे? Can it be oxidized under normal conditions?
No,
Not at all. इसके पास तो एक भी oxidizable hydrogen नहीं है, सारे के सारे तो alkyl group हैं, तो इसीलिए हम बोलते हैं कि no oxidation व no reaction. तो ये हो गया मेन डिफरेंस. 1-degree अल्कोहल के साथ अगर हम ऑक्सीडेशन करना चाहें विद स्ट्रॉन्ग ऑक्सीडाइजिंग एजेंट लाइक एसिडिफाइड पोटेशियम डाइक्रोमेट K2Cr2O7 प्लस H2SO4, तो रिएक्शन जो है वो शुरू में एल्डिहाइड प्रोड्यूस करेगा, लेकिन उस एल्डिहाइड को आप रिएक्शन मिक्सचर से बाहर नहीं निकाल सकते बिकॉज दी aldehyde easily further get oxidized to carboxylic acid. Again, I am repeating, if you take a strong oxidizing agent like acidified potassium dichromate, तो 1-degree alcohol पहले aldehyde form करता है, but within a fraction of second ये जो aldehyde है वो automatically oxidize होता है carboxylic acid. तो hence what you get in oxidation of 1-degree alcohol with strong oxidizing agent is not an aldehyde. It's not possible to take out the aldehyde because it is formed during the course of the reaction. So ultimately what we get is the carboxylic acid. 2-degree alcohol को अगर हम strong oxidizing agent के साथ react करें तो उसका तो एक ही destination है ketone, क्योंकि ketone तो further oxidize नहीं हो रहा है, तो इसलिए ketone is the final product. और 3-degree अल्कोहल तो ऑक्सीडाइज होता ही नहीं है जब तक उसको ड्रास्टिकली ऑक्सीडाइज ना करो. तो ड्रास्टिक कंडीशन में द बॉन्ड स्टार्ट ब्रेकिंग, तो वी आर नॉट गेटिंग इनटू द ड्रास्टिक कंडीशन, लेट इट बी नॉर्मल कंडीशंस. तो इसीलिए हम कहते हैं कि अगर 1-degree अल्कोहल को अगर ऑक्सीडाइज करें तो फाइनल प्रोडक्ट हमको एल्डिहाइड नहीं मिलता है, लेकिन देयर इज अ वेरी सिलेक्टिव ऑक्सीडाइजिंग एजेंट जिसका नाम है पिरिडीनियम क्लोरोक्रोमेट, जिसको शॉर्ट फॉर्म में कहते हैं पीसीसी, पिरिडीनियम क्लोरोक्रोमेट. याद रखना, ऑलमोस्ट इन एवरी एग्जाम एवरी ईयर इट इज आस्क्ड इन वन वे और द अदर. तो जो पिरिडीनियम क्लोरोक्रोमेट है उसके साथ अगर हम ऑक्सीडाइज करें 1-degree अल्कोहल को, द रिएक्शन विल नॉट कंटिन्यू फर्दर to oxidize the aldehyde to carboxylic acid. मतलब it will put a break. after aldehydes are produced. So pyridinium chlorochromate strong oxidizing agent हुआ कि mild oxidizing agent हुआ?
Sir, mild.
Mild, क्योंकि strong जो है वो किसी तरह का break नहीं put कर सकता, तो carboxylic acid is the ultimate product. लेकिन अगर हम PCC यूज करें तो aldehyde is the product because it will prevent further oxidation of the aldehyde to carboxylic acid. अच्छा, सेकेंड रिएक्शन में पीसीसी दो या स्ट्रॉन्ग ऑक्सीडाइजिंग एजेंट है दो, कोई फर्क नहीं पड़ता, क्योंकि स्ट्रॉन्ग देने से भी कीटोन ही फॉर्म होता है और माइल्ड देने से भी कीटोन ही फॉर्म होगा। तो 2 डिग्री अल्कोहल्स जो हैं वो कीटोन प्रोड्यूस करते हैं। तो यहां पर ध्यान देने लायक एक बात है कि 1 डिग्री अल्कोहल में जो OH ग्रुप होता है वो कॉर्नर कार्बन के ऊपर होता है, और कॉर्नर कार्बन के ऊपर अगर OH हो तो पहले वो एल्डिहाइड प्रोड्यूस करेगा, और एल्डिहाइड जो है वो हर समय कॉर्नर में ही रहता है, और फर्दर वो कार्बोक्सिलिक एसिड प्रोड्यूस करेगा जो कि कॉर्नर में ही रहता है। बट 2 डिग्री अल्कोहल जो है उसमें OH ग्रुप कभी कॉर्नर में नहीं रहता, बीचों बीच रहता है, एंड अकॉर्डिंगली कीटोन्स प्रोड्यूस करेगा, बिकॉज कीटोनिक ग्रुप इज नेवर एट द टर्मिनल, ketonic group is always somewhere in between, and that is why 2 degree alcohol gives ketones and 1 degree alcohol give aldehydes first and then carboxylic acid. समझ में आया यहां तक? Yes, any doubt? Please clear it out.
Sir, can you repeat once again?
1 degree alcohols have how many oxidizable hydrogen? 2 oxidizable hydrogen, and that is why 1 degree alcohol shows oxidation in 2 steps. In first step, upon oxidation, what will it give you? Yes, tell me. In the first step, upon oxidation, 1 degree alcohol will give you what? It is there on the board.
Yes, sir, but what is the art thing?
Yes, anyone can answer me. 1 degree alcohol.
Sir,
aldehyde. Yes, but that aldehyde cannot be taken out if the oxidizing agent is strong oxidizing agent, as the aldehyde quickly further gets oxidized to carboxylic acid. So 1 degree alcohol, aldehyde produced and the carboxylic acid produced all contain same number of carbon atoms in them. Acha, come to 2 degree alcohols. 2 degree alcohols have how many oxidizable hydrogen in them?
One.
One. So it can show one step oxidation only. So 2 degree alcohol will give rise to what kind of compound upon oxidation?
Ketone.
It will give you ketone. Why 3 degree alcohols do not undergo oxidation?
Sir, because they do not have
does not have
oxidizable hydrogen.
They do not have any oxidizable hydrogen in them, and under normal conditions 3 degree alcohols can never be oxidized. Up to this much, is it clear?
Yes, sir.
Yes, sir.
Okay. Now if you want that aldehyde should be produced from 1 degree alcohol and it should not get oxidized further to give you carboxylic acid, then which specific reagent should be used?
So pyridinium chlorochromate.
Yes, pyridinium chlorochromate. In short, pyridinium chlorochromate is called what?
So PCC.
Sir,
PCC. Okay. Shayantan, is it clear up to this much?
Yes, sir.
Okay. So start writing. Different alcohols produce different products upon oxidation. Different alcohols produce different products upon oxidation. 1 degree or primary alcohols upon oxidation with strong oxidizing agents give carboxylic acids via formation of aldehyde, all containing same number of carbon atoms. Suppose I take ethanol, which is 1 degree alcohol. So if you treat this with K2Cr2O7/H plus, at first it will give you ethanol, which is an aldehyde, but immediately it gets further oxidized to give you ethanoic acid. However, the reaction can be stopped after aldehydes are produced if the oxidation is carried out with pyridinium chlorochromate PCC. So same ethanol when you treat this with PCC, the product formed will be ethanol and no further oxidation will occur. Tell me after you have completed writing.
Done, sir.
Done. So there are various other reagents like PCC, but for our syllabus, we need to at least remember PCC. What kind of oxidizing agent is PCC?
So mild.
Or mild oxidizing.
Mild. Yes. You can also use the term selective oxidizing agent. So further you continue with 2 degree alcohols. A 2 degree alcohol readily gets oxidized to produce ketone containing same number of carbon atoms. So because it has one oxidizable hydrogen, so there is no problem in oxidizing it to ketones. But thereafter, oxidation, just like as aldehyde was showing, it was easily getting oxidized to carboxylic acid. Here that will not happen. So suppose you have a 2 degree alcohol, जहां पर OH है सेकेंड कार्बन पे, तो अगर इसको ऑक्सीडाइज करें स्ट्रॉन्गली लो या सिलेक्टिवली लो, पॉसिबिलिटी एक ही है, जहां पर OH है वहां पर कीटोनिक ग्रुप जनरेट होगा, और क्योंकि OH बीचों बीच है तो कीटोनिक ग्रुप भी बीचों बीच ही प्रोड्यूस होगा। अगर कॉर्नर पे होता OH 1 डिग्री होता तो कीटोन नहीं फॉर्म हो सकता था, एल्डिहाइड होता, लेकिन एल्डिहाइड वाज फर्दर गेटिंग ऑक्सीडाइज्ड टू कार्बोक्सिलिक एसिड इफ द ऑक्सीडाइजिंग एजेंट इज स्ट्रॉन्ग। तो यहां पर एक ऑक्सीडाइजिंग एजेंट हमने दिया है, वन मोर ऑक्सीडाइजिंग एजेंट व्हिच इज वेरी ऑफन यूज्ड इज क्रोमिक एनहाइड्राइड, chromic anhydride CrO3. So CrO3 is strong oxidizing agent just like K2Cr2O7/H+. तो कीटोन फॉर्म होने के बाद फर्दर अगर आप ऑक्सीडाइज करना चाहते हो तो नॉर्मल कंडीशन में नहीं होगा, यस ड्रास्टिक कंडीशन मतलब हाई टेम्परेचर में अगर हम कैरी आउट करें तब कीटोन भी ऑक्सीडाइज होगा, but in that case ketones will not be able to maintain their carbon as there will be carbon carbon cleavage, टुकड़े टुकड़े हो जाएंगे कीटोन्स के, छोटे छोटे कार्बोक्सिलिक एसिड प्रोड्यूस करेंगे. So we are not going to that, we are not going to get into the drastic conditions, we want to keep them in normal conditions. A 3 degree alcohol cannot be oxidized under normal conditions. क्यों नहीं ऑक्सीडाइज कर सकते 3 डिग्री अल्कोहल्स को?
Sir, because they do not have oxidizable hydrogen.
As they do not possess oxidizable hydrogen. बोलो तो आइसोप्रोपाइल अल्कोहल क्या प्रोडक्ट फॉर्म करेगा अपॉन ऑक्सीडेशन? एल्डिहाइड, कार्बोक्सिलिक एसिड, कीटोन क्या प्रोड्यूस करेगा आइसोप्रोपाइल अल्कोहल? आइसोप्रोपाइल अल्कोहल कीटोन, वेरी गुड. ये हो गया आइसोप्रोपाइल ग्रुप. तो अगर हमको पूछे कि आइसोप्रोपाइल अल्कोहल अपॉन ऑक्सीडेशन विल गिव व्हाट, तो सबसे पहले क्या देखना पड़ेगा? व्हाट इज द नेचर, क्या नेचर है इसका?
2 degree.
2 डिग्री. तो 2 डिग्री के बारे में तो ऑलरेडी बता ही चुके हैं. कितने ऑक्सीडाइजेबल हाइड्रोजन है 2 डिग्री के पास? एक ही है. तो 1 स्टेप ऑक्सीडेशन होगा और 2 डिग्री अल्कोहल जो है वो कीटोन प्रोड्यूस करेगा. ठीक है. Is it clear up to this much?
Yes, sir.
Okay. तो ऑक्सीडेशन हो गया, डिहाइड्रेशन हो गया. Is category number 3 still going on? The third type of reaction was reactions involving ROH as a whole. कोई इंडिविजुअल क्लीवेज नहीं हो रहा है. और यहाँ पर हम सबसे ज्यादा डिफरेंस देख रहे हैं 1 डिग्री, 2 डिग्री और 3 डिग्री के बीच. Previous two type of reactions, we were not emphasizing on the nature of the alcohol. We were emphasizing on particular bonds, either C bond O or O bond H. तो तीसरी तरह का रिएक्शन है वो है डिहाइड्रोजनेशन. डिहाइड्रोजनेशन क्या होता है? डिहाइड्रोजनेशन नाम के अनुसार
रिमूवल ऑफ हाइड्रोजन.
रिमूवल ऑफ हाइड्रोजन. तो यहां पर भी जो है 1 डिग्री, 2 डिग्री और 3 डिग्री एल्कोहल्स, दे विल रिएक्ट डिफरेंटली. क्यों? ऑलरेडी हम बता चुके हैं कि हाइड्रोजन्स आर डिफरेंट, ऑक्सीडाइजेबल हाइड्रोजन्स आर डिफरेंट. तो अगर हम यहां पर 1 डिग्री एल्कोहल लें, 2 डिग्री एल्कोहल लें और 3 डिग्री एल्कोहल लें, तो I have specified here some particular alcohols. So here you can see that in 1 degree alcohol there are 2 oxidizable hydrogen, as I have been saying. In 2 degree alcohol there is 1 oxidizable hydrogen. In 3 degree there is no oxidizable hydrogen. तो dehydrogenation में पहली बात जो ध्यान रखना है, this is carried out in vapor phase. Vapor phase माने सारे के सारे जो अल्कोहल हैं इनको वेपराइज करना पड़ेगा ताकि they can be passed over heated copper at 573 Kelvin, जो कि है तुम्हारा 300 डिग्री सेल्सियस. ओके, तो यहां पर क्या होगा? इफ यू पास द वेपर्स ऑफ 1 डिग्री अल्कोहल ओवर हीटेड कॉपर at 573 Kelvin, there is loss of hydrogen in this way. ये जो दो हाइड्रोजन है, एक ऑक्सीडाइजेबल हाइड्रोजन और एक फंक्शनल ग्रुप का हाइड्रोजन, ये भी ऑक्सीडेशन ही है. डिहाइड्रोजनेशन इज नथिंग बट ऑक्सीडेशन ओनली. प्रोडक्ट फॉर्म होगा एल्डिहाइड. तो प्राइमरी अल्कोहल्स अपॉन डिहाइड्रोजनेशन गिव एल्डिहाइड. सेकेंडरी अल्कोहल as usual they will lose hydrogen, and when hydrogen is lost, here the product formed is a ketone. So 1 degree is producing aldehyde and 2 degree is producing ketone. अब बोलोगे 3 डिग्री एल्कोहल के पास तो ऑक्सीडाइजेबल हाइड्रोजन है ही नहीं, रिएक्शन होगा कि नहीं? रिएक्शन होगा, लेकिन एक दूसरी तरह का रिएक्शन होगा. जब आप इसका वेपर कॉपर के थ्रू में पास करोगे तो रादर देन रिमूविंग द हाइड्रोजन, it will be water that will be getting lost, resulting in the formation of an unusual product which is alkene due to beta elimination. Dehydration का product alkene होता है, already हम discuss कर चुके हैं. तो out of 1 degree, 2 degree and 3 degree, dehydrogenation जो है वो 1 degree और 2 degree ही दिखाता है. 3 degree alcohols do not show dehydrogenation. What kind of reaction do they show? क्या रिएक्शन कहेंगे इसको? डिहाइड्रेशन. ठीक है, तो ये ध्यान रखना. सबसे पहली बात है, दिस इज अ वेपर फेज रिएक्शन. When the vapors of alcohols are passed over heated copper at 573 Kelvin or 300 degrees Celsius, different products are obtained depending upon the alcohol taken. 1 degree alcohols produce aldehydes, 2-degree alcohols produce ketones and 3-degree alcohols produce alkenes, which is completely out of the way. It is because of the fact that both 1-degree and 2-degree undergo dehydrogenation, but 3-degree alcohols, due to non-availability of oxidizable hydrogen, they show dehydration. So point-wise, we can write when vapors of 1-degree alcohols are passed over heated copper at 573 Kelvin, aldehydes are produced as a result of dehydrogenation. Can I rub the first reaction? Have you written it down?
Yes, sir.
Yes, sir.
When vapors of 2-degree alcohols are passed over heated copper at 573 Kelvin, ketones are produced as a result of dehydrogenation. Three-degree alcohols do not show dehydrogenation, rather they show dehydration, producing alkenes. Tell me after you have completed writing.
Sir,
Done?
right. Writing, sir.
हो गया? Can I proceed?
Yes, sir.
Yes.
Okay. So again, we get a difference between 1 degree, 2 degree, and 3 degree alcohols in dehydrogenation, whereas 1 degree and 2 degree both show dehydrogenation. 1 degree alcohols produce aldehydes, 2 degree alcohols produce ketones, but 3 degree alcohols, as usual, show exceptional behavior due to the absence of oxidizable hydrogen. So therefore, they prefer to show dehydration, loss of water, and loss of water will ultimately lead to the formation of alkenes. Now, if you are given a task to distinguish between 1 degree, 2 degree, and 3 degree alcohols, so we have already come across oxidation reaction and dehydrogenation, where the three alcohols react differently, isn't it? But we cannot use these reactions for test for distinction. Can anybody tell me why? Have you got my question? My question is, suppose you are given 1 degree, 2 degree, and 3 degree alcohols to distinguish. You are given a task to recognize which is 1 degree, which is 2 degree, and which is 3 degree. Even though we have just now come across oxidation reaction, dehydrogenation reaction, where the three different type of reactions are shown by different alcohols, then why can't we use these two reactions as test for distinction? हम क्यों इन रिएक्शंस को टेस्ट ऑफ डिस्टिंक्शन के अनुसार हिसाब से यूज नहीं कर सकते? कोई बता सकता है?
So in these reactions, the products are same only that are produced by 1 degree, 2 degree, and 3 degree.
No. 1 degree is producing aldehyde, 2 degree is producing ketones. Products are not same. सुजल,
Yes, sir.
कोई आइडिया है?
सर सोच रहा हूँ.
सोचो, बताओ. Anyone from girls who can answer me this question? क्यों हम इन रिएक्शंस को टेस्ट फॉर डिस्टिंक्शन के लिए यूज नहीं कर सकते? कोई भी रिएक्शन अगर आप यूज करना चाहते हो टेस्ट फॉर डिस्टिंक्शन, कैसा होना चाहिए रिएक्शंस? कोई भी रिएक्शन हम यूज कर सकते हैं टेस्ट फॉर डिस्टिंक्शन, या कोई स्पेसिफिक रिएक्शन हम यूज करते हैं फॉर टेस्ट? हाँ, कैसा स्पेसिफिकेशन कैसा होना चाहिए? किस तरह के रिएक्शंस को हम टेस्ट फॉर डिस्टिंक्शन के लिए यूज कर सकते हैं? दैट इज माय क्वेश्चन. ओके, मैं बताता हूं. जो कोई भी रिएक्शन जिसमें प्रेसिपिटेट फॉर्मेशन हो, या कलर चेंज हो, या किसी तरह का स्मेल आ रहा हो, which can be observed. You understand what's the meaning of which can be observed? जिसको देख के हम बता सकते हैं कि ऐसा रिएक्शन हो रहा है. Only those type of reactions can be used as test for distinction. समझ में आया? हर कोई रिएक्शन ऑब्जर्वेबल नहीं होता है. अब यहां पर एल्डिहाइड प्रोड्यूस हो रहा है, कीटोन प्रोड्यूस हो रहा है, लेकिन कोई स्पेसिफिक ऑब्जर्वेशनल चेंज नहीं हो रहा है. You cannot make out by looking at the reaction that yes, aldehyde is produced or ketone is produced or carboxylic acid is produced. तो इसीलिए हम जितने अभी रिएक्शंस डिस्कस कर चुके हैं, whether it be oxidation, whether it be dehydrogenation, none of them can be used as test for distinction. Understood or not? समझ में आया कि फिर से रिपीट करें? Tell me if you are not clear about it. Tanishka?
Yes, sir.
Have you understood what I have just now said? That why oxidation and dehydrogenation cannot be used as test for distinction between 1 degree, 2 degree, and 3 degree alcohols?
Yes, sir. So I understood that like the test for distinction is for the reactions which are observable. But the second thing I did not hear, sir. Can you repeat?
No, I have got my answer from you.
Yes, sir.
Only those reactions can be used as test for distinction, which gives us some observational changes that we can make out with any one of our senses, either by looking at it or by taking the smell out of it. Okay, so can you say esterification is a test for alcohol? We have come across esterification where alcohols are reacting with carboxylic acid to produce esters, and this reaction can be used as test for distinction. What makes it suitable to act as a test for alcohols? What is the nature of esters? The esters that are produced have some specific nature. What is the nature of esters? Have you gone through esterification, a very, very important reaction? Do you remember esterification? No? When alcohols, just go through the notes because I want you to know it now. It's a very important reaction. Just go through the reaction of alcohols involving cleavage of O bond H. See, we have discussed esterification there. So what is the importance of esterification? Why this reaction can be used as a test? सुजल देख के बताओ तो, पिछले क्लास में कराया था. Do you have the things written? Just see. Anyone who has written esterification कहीं पे लास्ट क्लास में डिस्कस किया था, देखो तो. Vedansh, do you remember?
I'm searching for this.
Okay, so let me tell you that esterification is a special test carried out to detect the presence of OH group. Now, what is esterification? Esterification is, as the name implies, is a process by which esters are formed. How can you prepare esters? You can prepare esters by reacting alcohols with carboxylic acids. The speciality of esters is whenever they are formed, you get very sweet smell coming out of them. Okay, so because the smell is used as a test, smell can be observed with the help of one of our senses. So therefore, esterification can be used as a test. So why am I giving you the example of esterification here? Because I just want to say that whenever you carry out any test for distinction, the reaction chosen should be such that some specific observational changes, either in the form of precipitate formation or in the form of color change or in the form of smell, should be carried out. Neither oxidation nor dehydrogenation can be used to distinguish between 1 degree, 2 degree and 3 degree alcohols because you do not get any specific observational changes. So what reaction can be carried out then to distinguish between the three types of alcohol? So write down the next question. How will you chemically distinguish between 1 degree, 2 degree and 3 degree alcohols? How will you chemically distinguish between 1 degree, 2 degree and 3 degree? So listen very carefully, a very, very important part. There is a test called Lucas test. The reagent which is carried out in Lucas test is called Lucas reagent, which is combination of concentrated HCl and anhydrous ZnCl2. Remember, so this combination is called Lucas reagent. No matter whatever be the alcohol taken, when it is treated with concentrated HCl in presence of anhydrous ZnCl2 acting as catalyst, we have discussed this reaction many a times. So what generally happens during the reaction is water comes out of it and you get alkyl chloride. So during this transformation, we see that alcohol is getting transformed to RCl. Now you know that ROH, alcohols are soluble in water, RCl is not. So previously when you take ROH in concentrated HCl, okay, so obviously this particular, because alcohols are soluble in water, so you get a clear solution initially, but slowly after the alcohol are treated with this Lucas reagent, it is getting transformed to RCl, which is insoluble. Now when two liquids are insoluble with each other, when you are mixing two liquids which are insoluble with each other, what is the pattern that you observe? Do you get a clear solution or you get a turbid or unclear solution? Yes. When two liquids are immiscible with each other, insoluble with each other, what kind of mixture do you get? Do you get a clear solution or unclear solution?
Sir, unclear solution.
Unclear solution. Now, when previously it was alcohol, it was a clear solution because alcohols are soluble in water. But slowly when alcohols are treated with this combination, so they are getting converted to RCl, and as they are getting converted to RCl, what kind of solution do you get? Clear or unclear solution?
Unclear.
Unclear solution. Okay. Now this reaction involves the cleavage of R bond O, and we know that the reactions which involve the cleavage of R bond O, the reactivity order is 3 degree greater than 2 degree greater than 1 degree, isn't it? Because the reaction forms what kind of intermediate during the course of the reaction? If R bond OH undergoes cleavage, will it not form carbocation? Yes or no? When R bond OH is undergoing cleavage at this point, are you not getting carbocation? सुजल, कार्बोकेटायन मिलेगा कि नहीं?
Yes, sir.
और कार्बोकेटायन किसी भी रिएक्शन में अगर मिलता है तो कौन सा अल्कोहल सबसे ज्यादा रिएक्शन दिखाएगा?
3 degree.
3 डिग्री. इसका मतलब ये जो क्लियर से अनक्लियर सिचुएशन में जा रहा है, which alcohol will show you the fastest transformation? 3 degree, 2 degree or 1 degree?
So 3 degree.
3 degree. तो हम लिखेंगे 3 degree alcohols produce turbidity immediately with Lucas reagent. Three degree alcohols produce turbidity immediately with Lucas reagent. So again, I am explaining the whole thing. When any alcohol, 1 degree, 2 degree or 3 degree, are treated with Lucas reagents, they are converted to their respective alkyl chlorides. 1 degree alcohol will produce 1 degree alkyl chloride, 2 degree alcohols will produce 2 degree alkyl chlorides, and 3 degree will produce 3 degree alkyl chlorides. All alkyl chlorides are insoluble in water. They are immiscible with water. And when the liquids are immiscible, just like oil and water, when you mix them up, they are immiscible. So you get an unclear solution. And this unclear solution is referred to as turbidity. So how much time will be required to produce the turbidity, which we can observe with our eyes, helps us to predict the nature of the alcohol taken. If immediately the turbidity appears, it means that the alcohol under consideration was 3 degree, and that is why immediately the turbidity was occurring. 2 degree alcohols produce turbidity after 5 minutes. तो 2 डिग्री अल्कोहल जो टर्बिडिटी प्रोड्यूस करता है वो कितने मिनट बाद? आफ्टर 5 मिनट्स. सबसे ज्यादा रिएक्टिव है 3 डिग्री. सबसे लोएस्ट रिएक्टिव कौन है?
1 degree.
1 डिग्री. 1 डिग्री अल्कोहल्स do not produce turbidity at room temperature, but only upon heating. तो रूम टेम्परेचर में 1 डिग्री अल्कोहल जो है उसका रिएक्टिविटी सबसे कम है, तो इसलिए दे डू नॉट रिएक्ट एट रूम टेम्परेचर. जब तक उसको हीट ना किया जाए रिएक्शन मिक्सचर को, रिएक्शन नहीं दिखाएगा. सो देयरफॉर दे विल शो टर्बिडिटी ओनली अपॉन हीटिंग. तो ये रिएक्शन याद रखना, which can be used to distinguish between 1 degree, 2 degree and 3 degree. Again, I am asking, why specifically Lucas test is taken as test for distinction? Why not other reactions so far discussed?
Because we can see from observation.
We can observe. किस तरह का observation यहाँ पर देखने को मिल रहा है?
So turbidity, unclear solution.
The time taken for turbidity to appear. ठीक है? तो कौन सबसे ज्यादा जल्दी टर्बिडिटी प्रोड्यूस कर रहा है?
3 degree.
3 degree, and therefore turbidity appears immediately. And कौन टर्बिडिटी प्रोड्यूस नहीं कर रहा है रूम टेम्परेचर में?
1 degree.
1 degree. और बीचों बीच कौन है?
2 degree.
2 degree. So if you are given the hint that an alcohol produces turbidity with the Lucas reagent after 5 minutes, that means which particular type of alcohol is being talked about?
2 degree.
2 degree alcohol. तो 2 degree alcohol oxidation करने से क्या produce करता है? Ketones. So everything is interlinked and you should be aware of it. I hope this much is clear to everyone.
Yes, sir.
Yes, sir.
Okay. So please go through it and previous topics, because as we proceed more, so everything is interlinked. So esterification is one such important topic that I asked you. So just go through the video or the notes if you have written it down and see whether esterification was discussed or not, because esterification is another very important test for detecting OH group. तो कोई भी अल्कोहल 1 degree, 2 degree, 3 degree, कोई भी अल्कोहल esterification test दिखाता है, because it's a functional group test. This is not a functional group test. It is a test to distinguish between 1 degree, 2 degree and 3 degree alcohols. Okay? So we come to an end of alcohol topic. The alcohol part is over. So next class we'll take the phenol. So it is, what is phenol? It is alcohol only, but bonded to not an alkyl group, but benzene. Okay? Thank you. Good night.
Thank you, sir.